Hello students, in today's session we will discuss project evaluation and review technique PERT. First we will discuss what is PERT, then we will discuss the difference between project evaluation and review technique and critical path method that we have discussed in previous lecture, and at the end we will discuss various examples of project evaluation and review technique. So let's first start what is PERT. Actually, project evaluation and review technique was established in 1950s by US Navy. Project evaluation and review technique is based on a probabilistic model. Let's discuss parallel with critical path method. So here is the critical path method, CPM and PERT. Both are project management technique. PERT is probabilistic. PERT is probabilistic in nature. So it is a probabilistic model. CPM is deterministic. CPM is deterministic. Probabilistic means the duration of activity is not fixed. It cannot be determined because of many uncertainties. There are the chances of change in project duration. So that we tackle in probabilistic model. But when it is certain that particular activity takes particular days, then it is called deterministic. So normally such kind of model like deterministic models are observed in construction project. Application is in construction project, whereas probabilistic projects are normally research and development based project, where it is not fixed that when activity will come. There are the many chances that there are so many uncertainties which may delay the time, and sometimes when everything is in favor it may complete early. So probabilistic model is normally used in research and development. Moreover, PERT is event based. PERT is event based. It is more important to note that when particular activity is going to complete and when it is start. It is event based. Whereas CPM is activity based. In PERT, project evaluation and review technique, we more concentrate on time of completion of the activity. So the focus is on time of completion. Whereas in critical path method, the focus is not only on time but also the cost of activity. So it is you can say critical path method is trade-off between time and cost of the activity. So we can say in critical path method it is time and cost trade-off. So we use the example of crashing of network. We can take crashing of network. We normally use project evaluation and review technique in non-repetitive nature. It is non-repetitive because most of the R&D projects are non-repetitive. Say, if I want to develop a vaccine for COVID-19 coronavirus, it's one kind of research project. And it is not fixed at how much time it takes. Say for an example, clinical trial across the world. So the total time duration required for such clinical trial may extend or may, if it is in favor, may complete in lesser time. So it is probabilistic in nature and it is non-repetitive. Once it is identified, then there is a new project. So every time there is a new event, new project. Whereas in case of critical path method, it is repetitive in nature. For example, I am developing one construction of dam or bridge. So once in one place it is formed, it is constructed, on another place same project is again repeated. So CPM is deterministic in nature and repetitive in nature. Another difference is that in PERT we use 3 time estimates, and from this 3 time we get the estimated value of activity time. So here there are the 3 time estimates we use. We will discuss this in detail. 3 time estimates. Whereas in critical path method there is a 1 time approximation. 1 time approximation. And that is deterministic. And it is deterministic. So we can say that project evaluation and review technique is probabilistic in nature. It is normally used in research and development project. It is event based and more focus is on time of completion of activity. It is non-repetitive in nature, and there we use 3 time estimates: most likely time, pessimistic time and optimistic time. Whereas critical path method is deterministic in nature. We know the most likely time of the event. It is normally used in construction project. It is activity based and our focus is on time and cost both. It is repetitive in nature and we use only 1 time because it is deterministic. So now let's discuss project evaluation and review technique. So now we will discuss project evaluation and review technique. So in PERT, as you discussed earlier, that time is estimated on the basis of 3 different types. One is known as pessimistic time, let's say it is TP, and if we say here is somewhere times TP. Pessimistic time means when everything is not in favor of our activity and so there is a continuous delay in activity. That is known as a pessimistic time. In other sense, we can say that it is a maximum time would be taken by activity. Activity may take this time, that is a maximum time of an activity. So that is pessimistic time. Another is optimistic time. TO. Optimistic time means when everything is in our favor and so the entire activity is completed in minimum duration. That is known as an optimistic time. Say it is somewhere here. TO. Pessimistic time is the maximum time duration taken by an activity when everything is not in our favor and so because of uncertainties there is a continuous delay in completion of an activity. Whereas optimistic time means minimum duration taken by an activity to complete when everything is in favor and we are able to complete the activity. And third time estimate is most likely time. That is mentioned by TM. It is somewhere between, or you can say mean time. So most likely time means if I carry out this activity for 20 times, then in majority of case the activity is completed around this time. So that is most likely time. You can say it is when I carry out the activity on an average, this will be completed on TM. So as we have discussed earlier, that project evaluation and review technique is probabilistic in nature, and so it follow beta distribution. Beta distribution is uniform smooth normal distribution, you can say, where we give maximum weighted to mean value. And so from beta distribution we can calculate the estimated value of activity completion time, say TE, that is equal to pessimistic time plus 4 times most likely time plus optimistic time divided by 6. So here we give 4 time weightage to maximum most likely time. So it is around 66% weightage to the most likely time. So through this equation we can calculate the estimated time for an activity. Clear? Another, we can calculate the standard deviation. Sigma is equal to TP minus TO divided by 6, and variance is calculated as it is a square of standard deviation. So variance is equal to sigma square TP minus TO divided by 6 square. So in this way we can calculate the variance. So we can say that project evaluation and review technique is probabilistic in nature and follow the beta distribution. We take 3 time estimate: pessimistic time, optimistic time and most likely time. Pessimistic time is the maximum time duration taken by an activity when everything is odd, everything is not in favor, there is too much uncertainty. Whereas optimistic time is the time when everything is in favor and the entire activity is completed in minimum duration. And third time estimate is most likely time, that is time taken by an activity to complete in majority of cases. So from these 3 time estimates we can estimate the time for activity, that is TP plus 4 TM plus TO divided by 6. Here we give 66% weightage to the most likely time. So maximum weightage is given to most likely time while calculating the time estimates. The standard deviation for the activity is TP minus TO divided by 6, and variance is TP minus TO by 6 square, because variance is a square of standard deviation. So now let's calculate how to calculate the probability of an activity to complete in particular duration. So we have calculated estimated time and variance. Now let's consider that the beta distribution of PERT is approximated to standard normal distributions, and so we can say that statistics Z equal to x minus mu divided by sigma. Now let's calculate that probability of completion of project in C time unit. So we can say that it is probability of x greater than or equal to C. So x is a completion time. So we can say that probability of x greater than and C is equal to probability of, we can say that probability of x greater than or equal to C is equal to probability of z greater than or equal to C minus mu divided by sigma. So what value we get for the z, that we will check in standard normal distribution table. Z is equal to area under standard normal distribution curve. So let take a chart. It is a standard normal distribution curve. Here is a mean, and if it's a value of z, so the value is, for half part the value is this much. So from this value, from the table, we can calculate the probability of completion of the project. That we will check in example. By taking an example, we will calculate how to calculate the probability. Okay, so now we will discuss one example of PERT. Okay, so now let's discuss example on PERT. So consider the following network. Activities are given, and the activities are in a form of event to event, 1 to 2, 1 to 3. So there is no need to show the predecessors. So activities are provided. There are 3 time estimates: optimistic, most likely, and pessimistic time is also provided. And the question is the critical path duration, find the critical path duration of the network, and the standard deviation of the critical path. The question was asked in GATE 2009 for 4 marks. 2 questions were asked, so it is 4 mark questions in GATE. Let's quickly solve this example. First, calculate the estimated time, TE. Estimated time is equal to optimistic time plus 4 into most likely time plus pessimistic time divided by 6. So it is 8 plus 1, 9 plus 3, 12 by 6. So it is 2. So in this way we can calculate the estimated time, that is 2. For other activities it is 6, 5, 7, 4, 5, 6, 3. So in this way we can calculate the estimated time. And next step is to calculate the variance, that is square of standard deviation, or you can say just variance. Variance is equal to Tp minus To by 6 square. So Tp 3 minus To 1 divided by 6 square. So it is 4 by 36. 3 minus 1, 2 by 6 square. So it is 4 by 36. So in this manner we can calculate the variance. 4 by 36, here it is 7 minus 5, also 2, so it is also 4 by 36. 7 minus 3, 4, so it is 16 by 36. 9 minus 5, 4, 16 by 36. 6 minus 2, 16 by 36. 6 minus 4, 2, so it is 4 by 36. 8 minus 4, so it is 16 by 36. And 4 minus 2, it is 4 by 36. Let's verify it. 3 minus 1, 2, 7 minus 5, 2, 7 minus 3, 4, 4, 6 minus 2, 4, 5 minus. Okay. So here we have calculated the variance. So after calculating the variance, now we will draw a network diagram for identifying the critical path. So activity 1 to 2, 1 to 3 and 1 to 4. So from event 1 there are the 3 activities. Let's draw event 1. From it event 2, 3 and 4. Let's 1, 1 to 2, 1 to 3 and 1 to 4. Then 2 to 5, 3 to 5 and 5 to 6. So 2 and 3 both are terminating in event 5. So let's event 5 is here, somewhere here. 2 and 5, 2 to 5, 3 to 5. So 2 to 5 and 3 to 5. 5 to 6, 4 to 7 and 6 to 7. So activity 5 to 6. Now 6 to 7 and 4 to 7. So for activity 4 to 7 is terminating in 7. So we will draw like this. Activity 7 and activity 4 to 7. Now we will note down the estimated time of each activity on the arrow. So for 1 to 2 it is 2, 1 to 3 it is 6, 1 to 4 it is 5, 2 to 5 it is 7, 3 to 5 it is 4, 5 to 6 it is 5, 4 to 7 it is 6 and 6 to 7 it is 2. Now calculate the earliest start time. We can start activity 1 at 0 time, 1 to 2 will complete at 2 and 2 to 5 will complete at 9. 1 to 3 will complete at 6 and 4 to 5 will complete at 6 plus 4, 10. Out of this 10 is large. At 10 days all activities are completed. So we can start activity 5 to 6 at 10 days. 1 to 5 it is 5 days. Now 10 plus 5 15 days. And okay, so activity 5 to 6 is completed on 15 days. For activity 6 to 7 the duration is 3 days. So take here 3 days. So 6 to 7 will complete on 18 days and 1 to 4 completed on 5 days. 5 to 4 to 7 is completed on take 6 days, so it will complete on 11 days. So we will say that maximum time is 11. So project will complete on 18 days and the critical path is 2 plus 7 5, 9 plus 5 14 plus 13 17. So critical path is 6 plus 4 10, 10 plus 5 15, 15 plus 3 18 days. So critical path is 1 to 3, 3 to 5, 5 to 6 and 6 to 7, and number of days is 18 days. So the critical path duration of the network is 18 days and critical path is 1 to 3, 3 to 5, 5 to 6 and 6 to 7. Now next question is to calculate the standard deviation. For that what we will do, first we calculate the variance. We have already calculated the variance. So now variance of critical path, that is sum of variance of this critical path. So first is 1 to 3, so that is 4 by 36 plus 3 to 5, that is 16 by 36 plus 5 to 6, that is 4 by 36 and 6 to 7, that is also 4 by 36. So the total variance is 4 plus 4 plus 4 plus 16, so that is 28 by 36 days, that is equal to 0.77. Now in the question variance is not asked, in the question standard deviation is asked, and we know that variance is equal to standard deviation square. So we can say that standard deviation of critical path is equal to under root variance 0.77. So the answer is 0.88. So variance, so standard deviation of the critical path is 0.88. So let's quickly recap the example. Consider the following network. PERT network, activities are given, 3 time estimates are provided. We have to calculate the critical path duration of the network and standard deviation of the critical path. So we have calculated first estimated time. The step 1 is to calculate the estimated time, that is TP plus 4TM plus TO divided by 6. So we calculate the estimated time, and the second step we calculate the variance of the all activities, that is TP minus TO divided by 6 whole square. Then we have drawn the network diagram. Then we have calculated the earliest start time for all activities in fourth step. Then we have identified the critical path, and so we get the critical path. The total duration is 6 plus 4, 10 plus 5, 15 plus 3, 18 days, and critical path is identified. Then we have to calculate the standard deviation of the critical path. So we make the sum of variance of all critical path, and that is 28 by 36, so that is 0.77. And then we take the standard deviation. Standard deviation is under root variance, so it is 0.88. So in this way we can solve the example. Now in next example we will discuss how to calculate the probability of completion. For example, I want to know that what is the probability of completing this project in 20 days. The duration provided over here, that is estimated duration, as it is a probabilistic model. That is the estimated duration that my project will complete on 18 days. So in next example we will discuss how to calculate the probabilities for any PERT network. So let's discuss another example of PERT. Such kind of examples are many times asked in many competitive exams and university exams. So in this example, a PERT network is given with A to I activities. So 3 plus 3 plus 3, 9 activities you are provided. Their predecessors relationships is also mentioned. 3 time estimate, optimistic time, most likely time, and pessimistic time is given. And the question is, find the critical path and expected project duration. Second is, what is the probability of completion of the project in 25 days? So what is the probability that project complete in 25 days? And the last question is, if the probability of completing the project is 84%, then find the expected completion time. So let's start example. So first we will calculate estimated time TE. So let's calculate TE. TE is equal to, as we know, that is TO plus 4TM plus TP divided by 6. So it is 6 plus 7 into 4, 28 plus 8 divided by 6. So it is 8 plus 6, 14 plus 8, 22. 14, 22 plus 20, that is 42 by 6. So it is equal to 7. So it is 7. Similarly, we can calculate estimated time from B to I, that is 3, 4, 2, 3, 5, 3, 6 and 3. So these are the estimated time for all activities. The next step is to calculate the variance, that is sigma square. As you know, it is TP minus TO divided by 6 square. So it is 8 minus 6 divided by 6 square. So it is 2 minus 2 by 6, 1 by 3 square. So that can be written as 0.11. So let note down variance. Now we can calculate similarly for B2I activities. 1.7, 1.11, 1.78, 1.78, 0. See here the variance is 0 because for this activity optimistic time, pessimistic time and most likely time are same. So it should be 4, I think. Estimate time is 4 for activity. For activity H, it is 4 because the variance is very large. Minimum time is 2, maximum time is 14, and for activity I it is 1. So in this way we can calculate our standard deviations. Now next step is to form the network diagram. Let's keep this equation here. Probability of f greater than or equal to c is equal to probability of z greater than or equal to c minus mu divided by sigma. So first we will develop the network diagram. For activity A, B, C there is no predecessor, so we can start it from event 1. Event 1, activity A, B and C. Now D is from B, that it is activity A, B and C. Activity D is from activity B. From A it is E, so from activity A that it is E. From activity F it is C. And G is from E. Activity G is from E. H is from D and G both, so we can terminate D and G at some point. There's somewhere here. So activity H is from D and G both, and I is from F, and it's the last event, so we can say it is somewhere here. It is event I and terminate into last event I. 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 events in network diagram of 9 activities. Now we will write down estimated time quickly. For activity A it is 7, B it is 3, for C it is 4, for D it is 2, for E it is 3, for F it is 5 and G 4, F it is 5, for G it is 4, H and I it is 6 and 3, for H it is 6 and I it is 3. Now we will calculate the total project duration. A activity starts at 0 point, ends at 7 days. For E it is 10 days and for G it is 14 days. So H can start after 14, one option. B will complete on 3 days, 3 plus 2, 5 days. So out of this 2, 14 is I. 14 plus 6 it is 20. I will to calculate for I also. C will complete on 4. F will complete on 5. So 4 plus 5 it is 9. 9 plus 3 it is 12. So 6 H event H and I will complete on or before 20 days. So entire project duration is completed on 20 days. And so our critical path is 7 plus 3 10 plus 4 14 plus 6 20. So here is the critical path A, E, G, H. So the question is find the critical path. So that is critical path is CP is equal to A, E, G, H. Expected project duration is 20 days. Now we have to calculate the standard deviation for calculating the probability of completion of project. So standard deviation sigma. First we let's calculate the variance. variance of critical path. So the variance of activity A is 0.11 plus variance of activity E, that is 1.78, plus variance of activity G, that is 0, plus variance of activity H, that is 4. So total variance is equal to 5.89. 5 by 8 plus 1, 9, 1 plus 1, 8, so 5.89. And so we can say that standard deviation is equal to under root variance, so it is under root 5.89, and so it is 2.78, 2.43. 2.43. So the standard variation of the critical path is 2.43. So quickly recap, we have first calculated the estimated time, then we have calculated the variance, then we have drawn the network diagram, then we have calculated the earliest start time, from that we have calculated total project duration, that is 20 days, and identified the critical path. After identifying the critical path, we have calculated the variance of critical, and then we have calculated the standard deviation of the critical path. So let's note down here the standard deviation is 2.43 and project completion days, that is mu, mean duration is 20 days. Okay, so now we will solve another question. What is the probability of completion of project in 25 days? So we know that probability of x greater than or equal to 25 days, that is 25 days. So probability of z greater than or equal to c, that is our 25 minus mu, that is 20 days, divided by sigma 2.43. So probability of z greater than or equal to 25 minus 20 divided by 2.43, that is equal to 2.06. 2.06. Now check this value in table of standard deviation, area under normal standard distributions. So in table you will find two values. Here it is 0.12 like this, you will find somewhere 2, and here it is 0.01, 0.02, 0.09, so somewhere it is 0.06. So the value which falls under 2 and 0.06 will give you the area under the half part of the normal distributions. So this value is 0.4803. This value indicates this part. Say it is a normal standard distribution, and here is the mean value. It is 2.06, and the area under curve is 0.4803. So the total area up to 2.06 is 0.5 plus 0.4803. So that is 0.9803. So here the answer is 0.9803. You will find this table in the last of your book. So in last pages, this table is provided. So from that you will get the value of z, that is 9803. So we can say that the probability of completion of the project, is 98.03%. Clear? We will further calculate next question. So you will more acquaint that how to calculate the value of Z or how to interpret the value of Z in standard normal distribution table. Let's take another question. So the here answer is 98.03%. Now, if the probability of completing the project is 84%, find the expected project completion time. So here, probability of Z greater than or equal to probability of X greater than or C equal to 84%. So we can say probability of Z greater than or equal to C minus mu divided by sigma is equal to 0.84. So we can say that probability of Z greater than or equal to C is unknown for us. Mu is 20 divided by 2.43 equal to 0.84. Now check this value in standard normal distribution table. For that, first what we will do, we will minus half part of the table, so that is 0.5. So we will now check for 0.34 value. In table, if somewhere there is a value 0.338, let's take it somewhere here 0.338. So it is near to 0.34. So take this two value, it is 0.9, it is 0.09. So the value is 0.99. So in this way we can identify the value of Z. Here we have provided this value. We will take the nearest value of 0.34 in the table. So here the value is 0.99. In this case value is 0.99. So we can say that C minus 20 divided by 2.43 is equal to 0.99, from which we can calculate the value of C. Value of C is equal to 0.99 into 2.43 plus 20. So that is equal to 22.4 days. So we can say that probability of completing the project is 84% for 22.4 days. So in this way we can calculate the probability of completion of the project. So clear how to take the data from the standard normal distribution table and how to calculate the value of project completion durations.